This video is going to cover Unit 7, which is number 37 to 56 on the semester review. So, jumping right in, we want to match the given parts of the figure to the names. So, vertex is where three or more faces meet. So, let's see, we have triangle PUT. That's would be not a vertex. We have point T, which is this right here, and that is a vertex. So that is B. For an edge, that's going to be like a line segment. So looking at this, we have line segment PU, that's this one right here, and that is going to be the edge, so it is D. Oops. For a face and a base, you do have to be a little bit careful because the base, remember, is what it sits on, so that is a pentagon. So that would be, which I skipped, oopsie. But because my base is a pentagon, I'm going to go with pentagon PQRST. And then my face is going to be a triangle because it's not the base, but it is a flat surface on the shape. So for 41, we want to name vertices, edges, and bases. This figure, my bases are triangles because I have two of them. So this is a triangular prism. And my R looks kind of funky. Triangular prism. And so our vertices would just be all of these single points where three or more faces are coming together. So we have A, B, C, D, E, and F. So then for edges, you want to be a little bit careful because it is really easy to miss one on accident. So I just put little marks in it. We have DF, FE, DE, and that takes care of our top. Then we also have FC, DA, EB, so DA, EB, and then AC and BC. And technically all of these have little line segment symbols above them. And then our bases are just what shape is it and what are they? So we have triangle ABC and triangle DEF. And it doesn't matter if you have corresponding stuff together or not. You just have to have that info. And let me go back and highlight real quick. Boop, 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 boop. Okay, so continuing on. You want to figure out what shape is made with this net. So I always start with where are my bases? My bases are these two things because I should only have a maximum of two bases for prisms. So because there's two of them, I know it is a prism. And then because my bases are, they kind of look like squares, they kind of look like rectangles, I would accept either square prism or rectangular prism. So I'll leave that up to your imagination because technically every square is a rectangle, so you can go back and forth. For this one, I noticed that I only have one base. So because there's only one base, it is a pyramid. And the shape of my base is a rectangle, so it is a rectangular pyramid. And again, you're just picturing if you were to fold these little flaps up, what shape would it make? So for cross sections, remember it's like you're slicing that piece off and then looking at the bottom of the piece you cut off. So with this, I see that my cross section is this two-dimensional figure right here, which if you notice is a triangle. So just keep in mind, these should always be two-dimensional shapes. And then if we took this cross section of this cylinder, notice it makes a rectangle. And if you were to cut a cylinder and look at it straight on where you cut it, it would make a rectangle. Again, a two-dimensional shape. For 11.2, you had to find volume. So with these, remember big B is base area. So just in case you forgot, I'm going to write it. So since that is our base area, that would be 7 times 2 because it is a rectangle. And 7 times 2 is 14. And then our height would be this 3. So then when we find volume, volume is base area times height. So that would be 14 times 3. And 14 times 3 is 42. And even though this is a slanted prism, it does not matter because oblique prisms are going to have the same volume of a regular prism as well. And something to note with this is that your units are cubed. That is going to matter on the final. So for number 47, it's going to be a bit more difficult because we have a regular polygon as our base. So real quick, I'm just going to fill in that my height is 15 because I know that. It's this number right here. So for the base area with this one, remember you have to take a slice from your octagon. So I'm going to draw this slice over here so I have more space. So if I want the full angle of this slice, I would do 360 divided by the number of sides. So in this case is 8, and that would be 45 degrees. And then, if you recall, we have to take that slice and cut it in half because it's that act of cutting it in half that makes our apothem. And that's what we need for the formula. So, since we know the full side was 10, we know this would be 5 and 5. I don't know what's happening with my voice right now. And then to find this angle at the top, because now I'm only looking at half of it, you just do 45 divided by 2, and that gives us 22.5 degrees. So now I have an angle, I have a side length, and I need to know another side length. So this is opposite, and my apothem is the adjacent. So I would do tangent of 22.5 equals opposite over adjacent. So then we would multiply by a to both sides. So we have a times tangent 22.5 equals 5. And then we divide by tangent of 22.5 to both sides, which I'm going to run a space. Boop. And then when you do 5 divided by tangent of 22.5, you get approximately 12.071. Now, ideally, you're not rounding in this because the base area formula is 1/2 of your apothem times the perimeter. So if you're able to just have a running value in your calculator, if not, then you can round, but just make sure you show it in your work. But our perimeter, because we have 8 sides, would be 10 times 8, so that's 80. So then 12.07, and this is going to be without rounding, times 80, and then divided by 2 gives you about 482.84 approximately. So then our volume, because this is a prism, is still going to be base area times height, except now our base area is 482.84 and our height is 15. So then times 15, again, this is with no rounding whatsoever. That gives us 7,242.6. And we're rounding to the nearest tenth. So again, millimeters cubed because this is a volume and your units are cubed for this. Okay. Perfect. So if your answer is close to that, then you probably just had some rounding ahead of time, but it should still be okay as long as it is reflected in your work. So for 48, we're finding volume again, but we have a cylinder now. Again, even though it's slanted, it doesn't matter. I'm really just need these values. So big B is base area. So because my base is a circle, my big B is going to be pi r squared. And in this case, my radius is 1.5 because it's half of that diameter. And 1.5 squared is 2.25. So I actually just write my base area in terms of pi. That way I don't have to worry about any rounding. And then my height is 6. So then, because this is a cylinder, it's still going to be volume equals base area times height. So that would be 2.25 pi times 6. That does not look like a 6. 6. And when you do that, times 6, that gives you 13.5 pi, or When we multiply pi in, it gives us 42.4 around the nearest tenth. So 4, because it's 0.411. So that is our answer. And I totally forgot units. Oopsie. So our units will be kilometers cubed. Okay, and it's going to bug me that is a different color, so there we go. All right. For number 49, they're really just asking for the formulas, because what is the formula? So if we have a pyramid with base area B and height H, my volume is going to be my base area times height divided by 3, because it is a pyramid. And then with a cone, it's going to be almost exactly the same, except it's going to be pi r squared times h divided by 3. Notice the only thing that really changes is because a cone has a circle as its base, my base area is just the formula for a circle instead. So looking at this pyramid, I forgot to highlight, oopsie. But looking at the pyramid, we have a base that is 6 meters by 3 meters, so 6 times 3 is 18 meters squared, and then our height is 4 meters. So then when we are doing this, we're going to have base area times height divided by 3, so that is 18 times 4 divided by 3, and when you put that into your calculator, you get 24 meters cubed. Okay. For this one, the right triangular pyramid, and actually I'm going to highlight these two because these are important. So with the triangular pyramid, my base area is going to be 1/2 base times height because it is a triangle. So 1/2 base would be 8 and the height would be 3. And that would give us 12 miles squared. And then our height is going to be the 5. So when we plug into volume, it's still base area times height divided by 3. So that'd be 12 times 5 divided by 3. And 12 times 5 divided by 3. Okay, I did it in my head, but I just don't always trust myself. But it is 20 miles cubed. Okay. To find the volume of this cone, again, remember base area is pi r squared. So our radius is 2. So I'm just going to say this is 4 pi because it'd be pi times 2 squared, and 2 squared is 4. And then our height is 6. So when we want our volume, it's still base area times height divided by 3. So that's 4 pi times 6 divided by 3. So in terms of pi, we would do 4 times 6 divided by 3 to give us 8 pi. Or if we do 8 times pi now, we get our answer in terms around to the nearest tenth, which gives us 25.1. And if you're curious, it should be 0.13. So that 3 tells us to just keep the 1. And our units would be kilometers cubed. Again, don't forget your units on the final because it does matter. It's half a point. Don't want to lose it. So for 54, we are finding the volume of a hemisphere. So if you have your formula sheet handy, you will know that it is 4 pi r cubed divided by 3 to find this volume. So we are going to do 4 times pi times 18 cubed, because that is our radius, over 3. So 18 cubed times 4 divided by 3 gives us our answer in terms of pi, which is 7,776 pi. Or if we multiply by pi, that gives us 24,429. Oh, wait. I just realized we didn't even have to do this. Look at me not reading directions. But if you're curious, it's O2. And then again, units is inches cubed. So technically this is the only answer you need, but if you want to include it, you can. This is just extra. Oops. All right, so I'm just going to highlight all of it because it's bugging me. But for 55, we're going to do the exact same thing. Volume equals 4 times pi r cubed over 3. Our radius in this case would be 26 divided by 2, so that is 13. So volume equals 4 times pi times 13 cubed divided by 3. So to get our answer in terms of pi, we would do 4 times 13 cubed divided by 3. And that gives us 2,929.3 pi. And it's 0.33 repeating, but you can just leave it as 0.3. And then our units would be feet cubed. Okay. All right. So then for 56, which is our last one in this unit, we have a composite figure. And so to find the volume of this, you're just going to find the volume of the prism and the volume of the cylinder and then add them together. So if we start with the prism, it would be volume length times width times height, or base area, which is 9 times 4 times 5. And 9 times 4 times 5 gives us 180. And then for the cylinder, it's going to be volume equals pi r squared h because it's base area times height. So that would be pi 2 squared times 3. So that would be 12 pi, which is also equal, let's see, 12 times pi. Oops, wrong button. 37.699, so 37.70 is what I would round it to probably. So then when you add that to 180, that would give us 217.7, and only put 0.7 because it's nearest tenth. So then this is centimeters cubed because again, it is volume. So hopefully this video was helpful. If you have any questions, feel free to ask.